In this lesson we're going to look at the magnetic field that's produced by a wire that's carrying an electric current. So if you imagine here we've got a cable that's passing through a sheet of paper, and we're going to look at the magnetic field as it's projected on that sheet of paper. So let's imagine I've just closed the switch, the current flows, and the magnetic field would look like this. Okay, so the first thing you'll notice is the magnetic field shows a pattern of concentric circles with the wire passing through the center of those circles. Right, let's just make a note of that. Okay, so we've got concentric circles, and what happens as we increase the intensity of the current that's flowing around the cable? Well, the intensity of the magnetic field will also increase. So we can say that the magnetic field strength is proportional to the current that's flowing through the conductor. Next thing is the question of the direction of the magnetic field. Well, you remember that the current always flows from positive to negative, so in this particular example the current's flowing in this direction around the circuit, and it's therefore going down through the paper. Well, how do we know the direction of the magnetic field in this case? Well, there's a very easy way to remember. So all you've got to do is think about a screwdriver, right? So what we want to do is think about what's the direction of the current. Well, that's the direction that we want to screw the screw into the piece of wood or the piece of paper, right? So if we're going to do that, what way do we need to turn the screwdriver? Well, most of you, I hope, will probably have used the screwdriver, and you will know that to screw that screw downwards into the wood, into the paper, you need to turn the screwdriver clockwise, right, in that direction. So that tells you current going downwards, direction of magnetic field is clockwise. So we can draw our arrows in like this. Screw going downwards, turn screwdriver clockwise, magnetic field in a clockwise direction. What happens then when we reverse the direction of the current? There you go, we swap the terminals of the batteries around, so the current's now going again, as always, positive to negative, and this time it's going upwards through the paper. So think about our screw again. This time the direction of the screw is now going upwards. Alright, so change that over, and you'll know that to unscrew the screw, for the screw to move in that direction, that's to say out of the paper, out of the piece of wood, you've got to turn the screwdriver in an anti-clockwise direction. So that's the direction of the screwdriver, and the direction of the magnetic field is anti-clockwise. Now, just before we finish, I just want to introduce you to some important notation, and this notation is quite often used in exams. So in the case where you have an electric current going into a piece of paper, okay, this is often represented like this. So what you've got to think about is like a dart, okay, and so as you're watching the dart go away from you, what you see are the tails of the dart, right? So like that, okay, as it's going away from you. So I'm depicting this now as being an electric current going into the screen, all right, the dart's going away from me, and so there I draw a cross like that. That represents current going into the paper. So we've got current going in, we turn the screwdriver clockwise as we're going in, the magnetic field will be in a clockwise direction. In the other situations, I'm looking from above, what I'm seeing is the current coming out of the paper towards me. Okay, so I'm looking here from above, there's my eye, as I should have depicted here as well. There you go, looking from above. Okay, so I'm looking from above the paper, and this time the current's coming out of the paper towards me. It's coming out of the screen towards me. So this time I see the point of the dart coming towards me, so I draw the point there. So that means current coming out of the paper, and therefore I'm unscrewing the screw, which means I've got to turn the screwdriver in an anti-clockwise direction. Okay, so there we've got current into the paper. Here we've got current out of paper. That produces a clockwise field, this one anti-clockwise. In the next lesson we're going to take this a little bit further. Instead of looking at the magnetic field produced by a straight conducting wire, as in this case, we're going to look at the magnetic field produced by a solenoid. That's to say a wire that's wound into a coil. So we're going to complicate things a little bit there, and then after that we'll see how that current carrying solenoid can be converted into an electromagnet.